Alright, I'm about to take down this iRobot Roomba. This is one of the older versions. No fancy sensors, it's just got the bump on the front. So I figured I'm going to try to jailbreak it. I've got one of these Rev control hubs. Very popular with FTC. A lot of robotics for like high school audience. And I'm going to try and hardwire it up to that. Some of the tools I've got with me, I've got this precision screwdriver set, courtesy of Harbor Freight. I've got two different types of cutters. I got flush cutters and these sort of perpendicular line cutters. An X-Acto blade. I like using this sort of plastic pry tool. If you don't got one of these, they come in a lot of like smartphone repair kits, or you could just bite the bullet, use a flathead screwdriver, but I like to use this. Keeps the plastic nice, doesn't mar up a lot of things. And the last thing I've got is these JST VH type connectors. If you don't got these, they come like 2-day shipping on Amazon. You can get them from DigiKey if you want cheaper and you want more. But these are the connectors that these Rev hubs use to power the motors. So I've got some of these handy, and let's see how far we get today. So right off the bat, I think we're gonna need a screwdriver. Give it a flip, press this button, pull out the vacuum tray. One thing to note, we may need to come back. There is a blower motor in here. Flip it over, right off the bat. See a lot of these screws we've got to attack. A lot of them have these nice little arrows pointing to them. I'm gonna guess that if we take those off, we're gonna get a good look at the first layer of these electronics. So let's just go ahead. Start unscrewing them. Another tool that's nice to have, these little trays. You're gonna get a bunch of different types of screws. It's gonna be nice to sort them individually, just so you don't get them mixed up. And having some sort of system for knowing which screws you took out at which step is also gonna be nice. Me personally, I'm gonna work left to right. So I'm gonna fill up the container that's furthest to my left first. And that's how I'll know these are screws on the first layer. So we just go la-di-da, remove all these screws. Some of them are pretty stuck in there. So. But yeah, it's a bright and sunny day here in Pasadena. Not a lot else going on. Cat's trying to stick to the shade out there on the porch. And yeah, I mean, the main reason I wanted to do this, I think this style of Roombas are very intelligent. It bumps into a lot of stuff, and it kind of, the way it works is best I can tell without looking at any of the firmware or code or anything. It bumps into a wall, it turns a random angle, and then it sets off again. So it looks like we got that first thing off. I can remove this plastic a little bit. It's getting caught on this sort of sweeper. So we're gonna go ahead, we'll take it out. And this part just comes right off. I'm gonna pop the screw out and keep it in that first layer container. It is bright silver. It looks a good deal different. And just because I thought it was gonna fall out accidentally, but it's actually taking quite a bit. You could probably leave it in there. So take this, put it over here with the other parts. Now we can take this first plate off. Ooh, we get a good look at the battery here. We can see warning may explode if dropped. May explode if disposed of in fire. Okay, well, don't catch this on fire. Good lesson. It's got these nice little pull tabs. Oh, that is a nice battery. That is a very compact, easy to remove thing. I see the left and right drive motors right here already. That's a great sign. I'm gonna grab a trash can too. It's another good tool to have. Just 'cause we're gonna get a lot of like look at this. This is just like a curly cue of hair that came out. So we're probably gonna get dust and dirt. We'll be prepared for that. I do see my drive motors right here, so we're probably gonna pop those out. Other motors that we're gonna need to take care of. These do spin. The blower motor on the back spins. This is another thing that has powered movement. And so I want to migrate all of the control system over to this rev hub. If I want to get leads coming off this battery so I can use the same battery setup, we may have to get a little more involved with that. I think I can get to this PCB that these springs are mounted on. So take a look right here. This is how the battery connects. It's just got these springs and they're mounted on a PCB that's kind of nestled in there. So we'll see. We will see. That bump switch, probably wired up to something else. So deeper. Let's see how far we can go. One thing they did do that is very nice is it looks like this second layer of screws is all color coded. It looks like all the screws we need to remove to start taking off these components are gold colored, which is going to help a little bit. These rollers still spinning pretty freely. Strategizing the next move here. I think we're going to take out those gold screws, keep them sorted. Just trying to look through them, kind of lock their positions in my mind so I don't forget. And of course, we've got it on camera. I'm going to take out this silver screw here first. Let's see if that pops this plate off. And it does. So we've got a small little gear ratio going on here. We got little turn big times 2. So these are very fast motors going on. Okay, so that's one small housing taken off. Now we'll start removing these gold screws and sorting them in that second tray slot we've got. Screw. Just making sure those trays are actually engaged all the way to the bottom so they don't start breaking containment. Very classy, very suave. Just dropping the tools. It looks like with the last of those gold color screws, this gear ratio is popping free. And with it, we got the motor. So, on the bottom down there, there's springs that connect that terminal here. But this is the first motor that we're really getting access to. And we dumped our screws. So this is one solid thing. Try to take a close look at it, see if it is something we can remove as a whole unit. I'd prefer to keep it assembled if possible. Because this dropped in just like so. Screws 1 and 2. So only 2 screws hold that in. This whole assembly snaps together. It can be removed as a whole unit. So I'm going to go ahead and reassemble this just because it looks like we're not going to have to mess with this anymore. Got to make sure all these holes line up and then it snaps in place. It's pretty nice. You take this screw. This is one of the silver screws that we had. And I just put that right back in. So I guess just as a note to myself, we can assume that these silver colored screws are like probably for the internal housings if they color coded them really nicely. And it looks like these sort of yellowy, brassy screws will be removing these whole units. So let's see what else we can take out here. One of the motors we're going to want to get to, the drivetrain. So let's start taking away those yellow plate screws over here. Seems like my screwdriver is actually not quite thin enough to reach. No, it is. There we go. Took a little finesse. It doesn't quite want to come out, but it is getting really loose. Let's see. And there's another one here in the corner. And that's it, so just 3 screws. There's that one brass one we removed earlier. Trying to shake that screw free. There we go. Push that screw from the other side, get it to pop out. There we go. This is the complete wheel module. You see it's sort of spring loaded, and it's got this spring that runs and pulls on the far side of it. And that's how it keeps that wheel sprung and engaged. The back of the motor, this is probably what we're going to want to get at. I'm interested in seeing how this interfaces. It looks like it has this sort of slot connector, and this connects into a slot that's held deep right here. We can sort of see the wires on the back of the motor here. I see from left to right, red, black, gray, white, green. Order might have gotten scrambled there, just from the way I'm looking at it, but those look like they're going to be the way the motor's controlled. I'm guessing that's an encoder module plus power. It's not too bad. All right, deeper and deeper we go. Let's pull out the other wheel module now. So again, it's going to be those 3 yellow coated screws. They come right out pretty easy. And these are all Phillips head screws so far, so we haven't had any like tamper proof or difficult to remove screws. Everything's being pretty friendly to me right now. It's just coming out as easy as can be. The screws free spinning, but not all the way out. There we go. That's the other wheel module. Trying to tap out the screws that are still stuck in the housing. I'll just push on the outside with the screwdriver. Looks like spinning them out again. There's one more. Get it real wedged in there. There we go. So that's all the screws out in the tray. We got these 2 wheel modules now. So that feels like it's most of it. I see these 4 screws. They're probably going to take off this vacuum module. So this is like one of the little spinny things. It's like an agitator, base of the vacuum. Sort of scrubs the ground, releases any extra dirt. I always think of it more like a carpet brush. Again, putting all those brass screws in the same spot since they sort of hold this base layer together. I'm very happy with how they designed this. This is like a very friendly layout. It's very modular. Everything got these sort of interesting shapes that go together. All the gear ratios come off as a complete unit with the wheels, so it's very, very clean. Very well put together. Definitely learning from this. I'm wondering how this PCB is gonna look. It's probably gonna be another good spot to learn from them. So now we've removed all the screws, and it just slides right out. Look at that. Pretty easy. We've got clear access, and it looks like all these motors connect to the base through that sort of USB looking thing. I'm not sure I'd actually call it a USB, but it's got that same sort of like chip with traces on it, those long skinny traces transfer some sort of signal. This is very nice. I'm very pleased with how this looks. No encoders on this. I'm just seeing a red and a black wire come off. There is another twisted cable that's like red, white, yellow. It's connected to this sort of this green thing. That's where those wires are coming out of. Only red and black wires out of the motor, so it doesn't look like it has a shaft encoder on this motor. It's just a standard DC 12 volt motor. Looks like there's another. This housing is holding some sort of pulleys or gears to transmit the rotation between these two rollers. Notice how they're still paired. That's going on back here. I don't see any reason to change that. Really what I want to get to is those leads on the motor. Probably add my own soldering to it. I'll just solder an extra wire onto it. That's probably going to be the easiest way to get what I want to do done. All right, this is going inside. Our table is getting piled high now, but we've got this shell, and it looks like anything else we need is going to come from a different layer. The only screws we can see now are these silver screws. They are attached to this front bumper, and they slide with it. So we're going to take them off for the sake of science. We've got that third little tray, third from the left, that we'll start filling up. And let's just go for it. Let's see what happens. Try not to strip them. I mean, these are Phillips head, notoriously easy to strip, but nothing's really like over tightened or like really difficult to turn. It's all coming out pretty readily. Let's not lose our screws here. As these screws are coming off, we're starting to see this small lip come off. It's probably about like 1/8 of an inch thin. Probably just holds it to the bottom. I'm guessing it's gonna slide off of the top. That's just looking how it's gonna be. There's a lot of very clear evidence that these parts are all injection molded. I see these sort of indicators of screws and flows going on. Very nice construction. You got this ring coming off, put it in the parts file, and there we go. So it does slide off the top. There's a wire connecting it to the hole still. So let's try to be as friendly to that as possible. Let's see if there's any way we can sort of rotate this so we can see the back of it without damaging it. There we go. So you see this sort of red, black, white braided cable coming out. curious what signal is being sent to here. This is like another sensor going on. From observation of its operation, it's probably some sort of either infrared or scattered light signal. It looks like this clear bit on top is some sort of diffuser. It's got like this conical internal geometry if we look at it. Looks like a little conical shape. I'm guessing that the easiest way for the Roomba to find its homing station is like infrared signal. So that's probably how I'd do it. I think that'd be pretty cheap, and I don't know. That looks like a reflector of some sort. It's conical, roughly a 45-degree angle. I'm gonna guess that's what it is. So we're gonna go ahead and unscrew it. It is in there with these two silver screws. They're a good deal shorter. Oh, let's not strip that. A good deal shorter than the other silver screws we just removed. So we'll probably sort it in a different bin. And a good way to remind us of what it's for is put it right in there with that, yeah, that looks like an infrared LED. It's got 3 legs coming off of it and a black cap. I think that's an infrared LED. Let me put that all in there. Got the battery. Oh man. We gotta do a little organization of this table over through this stack of books. Good enough. I'm gonna keep my screws and my tools close to my right. Battery there. It's interesting that they made that battery so easy to get to. Because it probably makes repairs easy. Maybe the battery's like one of the more commonly replaced components. Comes out super easily. And get our nice little tool tray organized here. Always important to keep a clean and organized workspace. That's just what we've done here. Much better. Alright. So he's looking a little sad now. He's still got these sort of whiskers. These look like little rubber stabilizers for the bump switch. We've got some of these. Ooh, that's interesting. It's like this compliant material housing a more rigid piece, and that creates this sort of like springy interaction going on here. This feels very, very soft. This is probably like 25A, 30A shore scale. And then this plastic is definitely more rigid. This is like, again, the injection molded plastic. Not 100% sure what plastic, but okay. So now we're looking at it. Feels like we're stumped. I think we're gonna have to start using this pry tool. A little clue to that, you see here we've got this sort of tab. I'm thinking that we're gonna have to attack that with our pry tool and come around this edge. Yeah, it looks like there's a couple of places where we probably have those snap in place tabs. So let's try it. I mean, let's see how it goes. Oh yeah, coming right up. And if you look, this is my clue that I was right. Little tab. It's got this sort of living hinge thing going on, snaps right back down. So we'll come around with the pry tool. Let's attack that other edge so you can see it. And then the great thing about this tool is you can just slide it under. Alright. Third time's a charm, let's go. Really trying to attack these one at a time. Let's see if we get this one on the first try. And it's up. And now if we look at the back, there's two more. These are a little sneakier, but it looks like that's how they're locked in. Probably a peg popping into there, so. See if we can bend the material up. Snaps right off. Ooh, and then we're stuck again. So now it looks like the majority of it is off. Towards this handle, it's getting stuck. I don't like how much I'm having to bend it. We might have been a little premature. It feels like it's being held down in the middle. I don't really want to break it. I'm just trying to look, see if we can get any extra hints. There are screws under this surface. There's not a lot of extra accessible screws here. Let's see, we'll just try to be as gentle can be. Really looking for any possible recourse here. I do see a screw coming through this black plastic here. I'm a little worried we're gonna have to take that out before we proceed. There we go. Okay, so now we can see it a little more clearly. It does have some extra resistance towards the middle. It looks like this sort of internal feature has another snap ring. I started prying here and the rest of it came loose. Doesn't look like we damaged it, which is good. So let's just set that to the side. If you've got like oh, what is that? There's like a US. That's an interesting connector. This looks like one of those old-fashioned mouse connectors here. This is probably some sort of data transfer, maybe a debugging. I imagine you could get that white panel off earlier than I did if you take off that that sort of bump cover. And then you just start prying. I imagine you get it off pretty quick without doing any of that extra takedown. So maybe this is like a diagnostic tool. It'd be interesting to see if we could control it directly from that without any of this hardware hacking. So maybe that's a bit of internet searching later. But so far we've got one more screw in that I laid aside before we started. We've got a bunch of these silver screws on top. It looks like I'm seeing two different sizes. This is the only one that looks to be a different size. flipping it back and forth. It looks like that connects the power poles that connect to the battery. We don't want to mess with that too early. We'll leave that one. We'll leave that one be. Doesn't even look like we'd be able to take it off if we did. I'm guessing these will take this carry handle off. Let's test that assumption. Carry handle, did it come off? Nope. Carry handle still stuck snug. Away we go. Let's take all these screws off. See where that leaves us. Turn these up side to side. It looks like those first two by the carry handle were probably about 2 millimeters, 1 millimeter shorter. Let's see if I have more of those yellow dividers. Quite nice. Just so we keep everything sorted. One more for good measure. Okay, there we go. Yeah, it looks like these are all the same size though. I don't want to be too premature taking this off, but it feels like it's ready to go. Definitely getting some resistance from this though, so let's go ahead and take it out. This one, it's smaller head size, so I'm gonna sort it out. Ta-da! Look at that. That is a beautiful first look at this. It does look like all this just slides right off. You can go ahead and take that out. There's 4 more screws holding this in. It's got this nice sort of effect where it's allowing these indicator LEDs to flash through. There's like a warning, a Wi-Fi symbol. Oh, looks like even better, it's just this black sheet and a semi-transparent sort of plastic piece. Black sheet goes behind it. It does have these clever little notches in it, so you can only put it in the right way. It's quite nice. We'll put that back and leave it be. Slide this ring over the top. There we go. We're gonna have to remove those screws to really get at these electronics. Look at this, looks like the actual smart part. See a QR code. And again, this little port here, I'm thinking maybe the best way to go about this doesn't involve taking out the hardware the way I really wanted to, which is a little sad, but I guess there's a better way to do it. I guess I don't have to, but I kind of want to do it the bad way, which is just soldering on these new cords and such. It just feels cooler. Do some quick resorting. I know these two shorter ones go with the carry handle, but that way now it's like left to right, top to bottom. If I swap these back and forth. I'm procrastinating a little bit. Starting to feel like I may be going about this the wrong way. So if you look at the way they control their buttons, got these plastic pieces, plugging hinges, and just these chonky buttons. This comes up pretty easily. It's still covered by this. Let's see if I can just peel that off. Yeah, a little foamy cover. Put that away in our tray. And this plastic sheet slides off. Looking at the PCB. It says 2018 iRobot, so I guess this is more recent. Working with it, it always felt unintelligent in some way. A little place for an extra antenna if I want to add some extra reception. Just looking at this circuit board, I don't know. I got the wrong major for being the one to really tell you much about that. J2, these cords look like they're all just gonna pop out, but I want to see what they're going to. So this is routed around here. The sensor hangs off the front. That looks like 2 more infrared LEDs. All of these have got like a LED and receiver pair going on. It does look like the most entertaining parts of the robot are on the bottom side of this PCB. Right off the bat, we know this one is for the battery connector. It goes to here. Or no. Scratch that. This is going to be the one that connects to the blower motor. This one, these wires are so thin, I'm not 100% what they control. Let's see, the battery connector is on the bottom side of that. We know that because we saw that earlier. I get a feeling that we're going to have to take off this PCB and see where the motor connections go, because I still want to solder to those. I think that's going to be the fun way to do this. Fun way, do this. Let's see, so this part goes here, and this plate comes under it. If it's put together like this, I'm looking oriented like this, trying to strategize where I can afford to put some holes for my own purposes. I think right here is going to be the most convenient spot to drill a hole. Just because I'm thinking I want to route the wires down. There's a little corner here that I could wire to the underside. Over here it looks a little risky just because there's some very intentionally like clear pathways on this outside face, so you're not messing with the messing too much with it. I'm gonna pull out my phone real quick. Oh no, you're using my phone, so I can't do that. All right, well, anyways, brief but strategic thinking. Oh, I wanted to get another screwdriver. That's what I'll do. Screwdriver. One more to hold these screws that I'm taking out of the PCB. Let's take out the one that I took out. Wow, coordination is getting a little weird there. Maybe it's just not a good angle for my wrist. It's a little strange. Alright. Dun, 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 dun. Oh, it's a little stuck. Looking at the underside. Okay, so all these wires connect to other stuff. On the back, I see places for big chunky solder traces that I could add. I'm gonna need to remember all the connections, maybe look at the bottom. So this is the one that has these two spring terminals. If I want to control that agitator motor, I can do that by soldering to these, and then by soldering to these are the connectors for the battery. VBAT in ground, so I'm guessing these are the terminals for actually getting voltage from the battery, and then these other two might be for charging. Just because when we put the battery like this, you see plus, ground, and then there's two more leads. I'm guessing these are for charging. It's good to keep those. So I guess the goal would be to get a wire connected to all three of those, all three of these, insulated for the rest of the way and routed out. But where are our drive motors? I mean, getting to the drive motors and the drive encoders, that's kind of the main goal I have. I don't know how useful this port is going to be yet. I don't think I'd be too upset about losing access to these buttons, but really, I mean, this is it's solid work. It's a robot. I don't want to like take out more than I gotta. Okay, but let's start looking at the other side if we can. I'm gonna unplug these. Remember which is which, so I can flip it and look. So. Those are very small traces. Could get very messy very fast if I start messing with them. And they're all on the other side. What were those three devices? So each one of these is one of the drive motors. Mech 1, Mech 3. This is that agitator. What was this one? What was that other device that had the USB connection? Was it this? It was this. So if we look at this drive motor. Oh, is that left or right? What are these? These are cute. Who drew these? Sorry, I'm getting distracted here. Alright, so drive motor. Looks like this one connects to the left. This is the left drive motor, this is the right drive motor. These look like accessories for all the different things. This is where that control comes out for that motor. This is where the control comes out for the carpet brush sort of attachment. How would I wire to that? Because that's the question. Well, I guess it's time to get out a multimeter and see what's connected to what. Oh, that's nice. I can put the screen here so we can both see it. This is just checking for continuity because so these traces are the same on both sides. It's a 6-wire connector. There's 6 different leads on the inside. Let me double check the inside of this. 1, 2, 3, 4, 5, 6. Yeah, so there's 6 different wires that are important to connect. If we look at the internals of this wheel, there's a limit switch, and I think that, yeah, so if we look on the inside of here, there's a limit switch. When the wheel hits maximum extension, that limit switch triggers. I'm sure that's data that's good to use. We'll just have to remember that. If I wanted to make this easier for myself, I would just get in here, tack some welds onto the motor itself. And then install it back as a module. It would still have access to all the data it needs. It would just have my extra sauce going on. I do like the idea of the wires coming out of the top. And while we got this PCB away, and while we've got access to the wires on top, thinking. A lot of thinking going on. I think we're gonna have to drill holes in the housing, and right now is the best time to do that. Just for the wires to escape. I don't think I want to add all these extra sensors as part of the goal. And before I start modifying this, I do want to check if I can just smarter not harder find some sort of connection to do that. If it's expensive, maybe I won't, but if it's relatively cheap and it's smarter than my current plans, no reason not to pivot and work a little better. So we'll put that back down. Remember that goes off. I'm struggling with that small connector. Alright, that goes right there. And this one goes right here. And second. R222. R223. What are those? Actually, never mind. We have a renewed interest in this. Let's see if we can see any connections. Do you see R222 or R223 over here? J24 and J11. Those are the J23, J24, J11. Those are the names of the connectors over there. Do we see those anywhere over here? I don't see any J's. Oh wait, this says J10. Maybe that's for different hardware that could be connected. Maybe in a later version of this, they actually have connectors here that attach to more advanced sensors. I know some of them got like a little LiDAR thing going on. I don't have my glasses on, so I'm getting real close to see these things. Alright, well, that's as taken apart as it can really get. I'm sure we could go all the way back and make sure it works properly. We're not going to put it back until we figure that out. So, I'm going to take a quick break, research what the hell this is, and then I guess we'll get back to it.